Hello everyone, welcome to this video. In this video, we'll be seeing this question which states that how can the factor group results in shrinking the size of Cayley table? So we already have studied about groups. We have studied about how to construct a Cayley table of this, right? So this represent all the calculations for some finite group. So now we are saying that factor groups in fact shrinks our Cayley table. How is this possible? So for that, let's take a finite group. Let us take the dihedral group D4, right, which is our favorite. So here it contains 8 elements, as you know, 4 rotations and 4 reflections. Now if you take a subgroup out of 8 which contains only this diagonal element and rotation by 180 degree, then we can construct the cosets of K within D4, right? So how you can do that? You can do it by taking each element from D4 and multiplying it with K. So that is what we have done here. We have took R0, R90, R180, R270, H, V, D and D dash, multiply it with K. So that means you have to multiply it with each element of K, correct? So, and you have to see this in the Cayley table. What are the operations? So you see this is K. In this case, it comes out to be R90, R270. In this case also it is K. In this case, it comes out to be again this one same. Right here with H, it comes out to be HV. With V, it is also the same. Right? Here I should write HK. And here with DK, it is DD dash. And with D dash also it is DD dash. So both of them, they are also same. So here you obtain this 8 cosets of K in D4, correct? Now using this distinct cosets, how many distinct cosets are there? One is this one which is K, one is this one which is R90K, right? They are not there, repeating. One is this HK, this is repeating. One is there, this is repeating. Now so that we have 4 distinct cosets for K in D4. So we can construct a quotient group out of it, right? D4 oblique K, consisting of these 4 members within it. Now once you got this, how now this is shrinking the size of the Cayley table? So for that, let us first of all see the Cayley table for D4. So you know this is the Cayley table for D4. Now what you do, if you shift R90 column with R180, right, interchange them, and here also if you interchange the rows and column, you'll see that in a moment why we are doing this, you obtain this, right? Now what you do, you just divide this into different blocks. Once you do that, into blocks of 2, taking 2 each, right? So that I have done by taking it by making green lines over here, right? So you can do this. Once you do that, once you have divided it into different blocks, so you see what is this R0, R180, it was your K. If you see it clearly, your R0, R180 was your K, correct? So what was your R90, R270? R90, 270 was your R90K, right? So you can write this as R90K. Similarly, here also you can write it like this K, and here also you can write it like this, right? And what is H and V and D and D dash? So you can see here H and V comes under HK and D and D dash comes under DK, right? So you can name them as HK and DK. Similarly, here also it is HK and it is DK, right? So as you can see, we can write them as K, R90K, not R0, R90K, right? And then this as HK and this as DK. Similarly here as well, right? And now these blocks within, they represent what? If you see clearly, they contains only the 2 elements, which are the first block R0 and R180. And what is it? This set is your K set. So instead of writing this 4 elements, you can now write K here. Similarly, instead of writing this HV here, you know what is it? It is HK. So you can write it HK here. So similarly, we can replace all of these blocks with the shorter forms here by the cosets. Thus, you see we can how simple it now became. A 8 cross 8 Cayley table has now been reduced to a 4 cross 4 Cayley table, right? So this demonstrates the power of quotient groups. It demonstrates how a factor group of D4 relates to the group itself, the Cayley table of the group itself, right? So basically we found a systematic way in which factor groups, they systematically collapse the elements of the group G, in fact the elements of the Cayley table of the group G. And in fact this could be done for any group in particular. So if we take a group G and its subgroup H, then we can construct the cosets AH from it, right, by taking A from G, which would contain A. So this cosets collapse to single group element AH in G. So that means all the elements which are member of this HK, so they would form one particular block. Here you see, because in our coset only two elements were present, so we have combined two elements at a stretch into one, right? So that means in this case our Cayley table shrinks to just the half of the group table D4. So I hope you understood this result and this very interesting property of factor groups well. Well, that is it for this video. Thank you for watching.